Oh hey, welcome to another edition of Hand-Laid Tracks and 3D Printed Trays with Socrates. Today we're looking at a number 6 Turnout with servo control. People have asked me about a number 6. I usually use number 4 on a small little track, but building a bit of an expansion there, and figured I'll make myself a number 6. I started with the number 6 fast track jig. It's a decent jig, but I prefer the 3D printed jigs. They're actually better with the heat. They're not as heat absorbing, so it's a little easier to do your soldering job. So this is a number 6 jig. It's got the ties for it. You can see in this case I put the wires on the frog ends as well. Some cases I run off the stub ends. I like to keep the wires everywhere I can. It's easier in some ways, harder in others. Anyway, it's got a frog power in the middle of it, and of course in this case a servo. They all run off the Arduinos is what I'm using for them, and this is just a regular micro servo. I tried hard to make the linear servos work, just didn't work out that well. In fact, this micro servo is really quite small. It's only, I think it's called a 2G. I have the servos now screw in, so if you decided that it didn't work with a small servo, you can just simply unscrew it from the whole piece of track and do anything with the track and screw in the larger one instead. And the larger servo fits in the same thing, and it would screw in the exact same place as the smaller one. Works exactly the same, a little more power if you need it. But it's a bigger hole, it's more invasive, it's a lot more work in some ways, it does more damage to the layout. So my jig systems, if you've seen the other ones pretty much, it's got a 3D printed jig, and you can see this has been used already once. Made that one with it, not too much damage for the most part. It's got little flanges on the side, so I have 3 sizes of clamps that go on it with some blocks, holds everything in place. The biggest task is to make the PCB boards, and this is one of my favorite things I came up with. There's a tie cutter and gapper. You put the PCB boards inside the individual slots and snip them off, and then once they're all in there, you file them all off to shape real quick using your Fast Tracks big file or some other big file. This is a really good file. Highly recommend the Fast Tracks file. Still use it all the time. And then once they're in there, you transfer them one by one into the other side, snap it in, hold it in place, and then using your triangle file, you go through and you put the gaps in it, because the PCB boards all have to be gapped, otherwise you'll have a direct short between the 2 different rails. And the most important and difficult ones to do is there's a couple with 3 gaps, and those are really annoying gap to get in the right place and just small enough. And this allows it to be done nice and easy, and it's nice and quick. And the end pieces can all be used to make all the normal straight and curved turnout or curved track pieces have a PCB board, all basically standardized. And what I'll do is I actually make a whole bunch of them at once, and whenever I make straight and curved tracks, I have these ready to go. It also has a frog maker, so you can put the frog in there. When you cut the frog, you want to solder it in places. This also has little ways to cut and bend the guardrails, so it's a length indicator here, and then you can put them in the holes and then bend the guardrails, because the guardrail has 2 little dips in it. One of the nice things about making your own tracks is you can be really fun with those little pieces, that little fine details. The edge of the guardrails and also the diverging rails, you kind of tap off that in that little corner, so it helps to guide everything in. It's one of the nicer things about making your own tracks. And when you're cutting the diverging rails, stock rails, and the frog rails, you have to sort of file off the edges ever so slightly of them. So I have a point and frog cutter, basically your jig, and you slip in your point rails, both point rails back to back. On the side says point. I don't know if you can read it in the sun. Very sunny in Amsterdam. And the other 2 are for the side marked frog. And then it's got a little line on it that shows essentially where the blocker goes. And you put the blocker on, and it shoves the rails in the right place while it's still loose. And it shoves the rail, put them in a little too far, and you put this on, and it then shoves the rail on this side in the proper place. You shove the rails in the proper place that side, tighten this down nice and tight, remove the 2 blockers, and now you've got your rails sticking out on both sides here, but they're aligned perfectly here. And then again, big Fast Tracks file, you file off that little bit of rail that sticks out, and that gives the frog the perfect little V shape that goes for the frog. And then the points also have the sides cut out as well. And you still have to cut the stock rails, and to do that you use the stock rail cutter, one rail at a time. It goes in, you mark it on the jig, and then you can cut the stock rail with this as well. I do use a Xeron cutter from Fast Tracks as well. Very good cutter, very, very helpful. So far for mine, I haven't had a problem with it. I've read some people have problems with it. I think it's on the bigger tracks. I made some HO, and it's definitely a whole lot bigger rail. There's no question about that whatsoever. And to do the actual Arduino, I came up with a very simple test board, basically. So I have some track ends that go on the ends of the turnouts, and then this is basically a split system because I'm running track power for just the tracks, and Arduino's on a completely separate circuit. So your switches have, it's a 3x3, so it's a double pole, I guess triple throw, or it's a triple throw double pole. I think it's triple throw double pole. But basically it has 3 different circuits that can flip. So one's red positive and black negative, saying that right I hope, and black being ground. And then the other side is the Arduino power basically. So the Arduino has to have a signal, high and low signal to it, can control the switch. And so I run through the Arduino power, the negative into the Arduino through this switch. So as you flip the switch, it switches that input from high to low. And I use on the Arduino, I use inputs number 7 and number 4 and 11. Sorry, use number 4 and number 11, and they're wired up here as you can see. And these go from the switch into the Arduino, and from the Arduino it controls the servos themselves directly. So when you flip the switch, you reverse the polarity on the frog, so the inner part of the frog switches power, but you also signal the Arduino to go ahead and reverse the servo direction. And the reason you need the board is, with the servos especially, they are, you basically set it up on the track close as it can be, and then you use the code to bump the servo a little closer, a little farther away. And it's a fairly simple Arduino code. I included as well. And the easiest way to do it is, because I could never remember anymore, I set one side the same as the other side, because basically it has a command that says servo move to, essentially, and it's like 100 or to 120 or so, and it's the degrees. So if you set them both at the same 100, when you flip the servo, the switch over here, it'll just stay to one side, and you know which side you're messing with, and then you can adjust the other side back, and you just sort of bump it up a little bit, little down, and you'll close the rails. If it goes too far, it basically will, it only has a quarter second, it'll hold it at power, and then it relaxes. So after a quarter second, if it's too much pressure against it, the servo is going to give up and push back anyway, because they don't leave the servos energized, they leave them just on the edge, so they sit there hopefully right. That's why, at least in one case, I switched to the bigger servo, because it has a lot more force in the unenergized position. So here's a video of me even longer talking over the entire build process. I have this video sped up about 5 times. I think it's about 1 hour and 50 minutes the whole video took from start to finish. Uploaded as well as the ASMR version of it, so if you want to watch the whole thing real time or see any particular detail, it's the exact same video that's going to be shown in time lapse, but you know, in normal speed. So this is the ASMR of me doing the whole turnout's about 1 hour and 50 minutes full time. I think this is about 5 times speed, about 15 minutes. Basically, I start with the Xeron snippers and snipping off the PCB boards. It's the one thing I get from Fast Tracks I definitely can't replace. There's not much left there, but this is again my favorite thing I came up with, which is this wonderful little jig, if I do say so myself. And you put the uncut pieces in the end of it, snip them off approximately to length, and then with the giant Fast Tracks file, you file them off down to one long length, and then, which doesn't take too long, it files pretty quick, and then transfer them into the big main body, and then once you snap them in, it holds it all in place up there, and then use the triangle file you pretty much just zap it down. Doesn't take very long, because you only really just want to cut through the one copper layer. Because basically, without the cut through it, you're going to end up creating a dead short between the two rails. So all the rails have to have a little tiny cut in them, and that cut has to be just right. Especially there's one right in there that's really hard to get in the right place, and that's one of the places that this jig really helps make a lot easier. And once all the ties have been cut, you also, I mean, you don't have to, but I guess it makes the solder work a whole lot better. But you run all the faces of the ties once back and forth quickly on the file, and then you slip them into the main jig, making sure that the cut part of the PCB board is facing upwards. I've made that mistake. And included is a bunch of little clamps and blocks that hold all the rails and PCB boards in place when you're doing your various soldering. And basically I'm using, again, I got it all from Fast Tracks. I guess it's Micro Engineering rail. Yeah, Micro Engineering. It's from the US, from Oregon. Although I think they went out of business, and hopefully they were bought again. I still think they exist. I use a little alcohol and a piece of paper towel and wipe the rails. Once I thought maybe I should check, and a lot of black gunk came off, so I thought, well, better to keep doing it. Basically, then cut your stock rails slightly too long, and as you can see, I bend the outside, or that one curved rail, just by hand, just sort of a little thumb pressure. They bend real easy in N scale, a lot harder in HO. I have a rail roller for HO, so you could do the same thing with a rail roller if you're doing an HO size. And then cut the diverging rails, because basically you have 3 sets of rails, 4 if you include guard rails, stock rails, which are the 2 outer long rails, one of which is just simply straight, diverging rails, which are the 2 that move, and the frog rails that form the V. And in this case, I'm making you have to trim the V for the frog rails and also the outer edge for the stock the point rails. And I have a little jig similar to the one, they have these from Fast Tracks. They're also pretty good. They're good, nice and weight, but I kind of like the way basically the plastic is sort of sacrificial. So there's a point where the plastic doesn't hurt my file the way the metal jig does. So you put the rails in a little bit long and a little bit loose, and the end caps shove the rails into the proper length in the proper place, and then tighten it down nice and tight. And I do make it pretty tight, and then pull the end caps off, and then once again, big file. What I do is I do the same number in one way, like usually about 10 to 12 one way, so about 12 the other way, then 10 another, then 8, 6, 5, 4, 3, 2, and that way it comes pretty evenly. And they've been coming out pretty good. I've been pretty happy with it. And you do 2 rails, or all 4 rails at once. You put the rail back to back, so the flanges are against the flanges, and you put the 2 frogs on the one side marked frog, and the 2 points on the one side marked point, and that way you can pretty much quickly do 4 out of your 6 different sandings. I clean the ends off a little bit as well. You want to get the tip so there's nothing too soft in there. And then there's a little frog jig as well, which also makes the guardrails, but you can put the 2 pieces of the 2 frogs in there with the little clamps again, and a block holds everything in place, and kind of force them in so they look like you kind of play with it where they force them in so they're not really deforming each other, but they're nice and snug. And then you hit it with some solder. That's my Weller 1010. I think the Weller's a great brand. Hit it with the solder a little bit on top, and then I file it just a little bit to make it smooth. And then for the most part, if you don't use too much heat, nothing's going to stick too bad in the jigs. I use a little tiny flat screwdriver to sort of pry things out lightly. And at that point, you've got to get your frog points done. Then place in the 2 bent stock rails to the proper place. Mark where I want to cut the edges of the stock rails, because you sort of cut a notch out. That way that the diverging rails come in and fit a little bit closer. And that's where the stock rail cutter comes in. It's either one edge or the other edge, depending on which rail you're putting it in. I use a black marker on the rail so I can see where it's supposed to start and how far I'm going to go back with it. And you want to go back a couple centimeters. And then you can like I say, you trim out the little edge on the one, and then you flip it and do the other rail, and once per rail. And then your 2 stock rails are done, and now you've got all your rails are trimmed at the very least, and all your PCB boards are cut to length and notched, and they're installed. And then I put in the frogs, and then it's time to do the diverging rails. Now again, the one end of the diverging rails has already been cut using our earlier jig, and one of the rails is straight and the other one is going to be slightly curved. Figure out exactly where it's going to go. Basically, you already have a notch on the stock rail that we just put the notch in, so you know where the diverging rail is going to go, because it's going to fit within the notch. And so once you get that in the right place, you can put your diverging rail in the right place, and then you mark approximately where it's going to bend, because you're going to have to cut a little teeny notch out of the side of the diverging rail using the Xeron tool. So you cut a little notch out and then you bend it, and that allows the little bend flange, because when you have your diverging rail, you're going to put that little bend in the rail right there. There, I'm putting it right then, and then you bend it in, cut it to length, and it fits in there. And this is one of those places where you take that tiny notch off the tip, which is sort of nice as well. And that's also, I'm also making it flat on the end too, but I'm also just generally cleaning it up. And at that point you have your two diverging rails in, and all your basic major work is done. You've got all your diverging rails in, your frog rails in, your stock rails in. What I do is I make sure everything fits at the same time. I don't really do one at a time. I am doing one at a time, but I'm doing them all at the same time as well. So I make sure everything sort of fits in the right place relative to itself. And I use a 3-point gauge, again from Fast Tracks. They're a really important thing and a great tool to have. That and the NMA metal gauge, those are both really important for the whole process. It keeps all the tracks in alignment. And what I'll do is doing the outside rail. Basically, the jigs all have sort of a round and square end, and you want to start soldering in the round end, because that way the tip of the soldering iron sort of pushes the tie farther in. First I use a little, the same small screwdriver I use to pop it out the little flat edge to push them all, jam them all into the squared edge. That way you have all your PCB boards on one edge. But then if you solder in the round edge first, it helps push the PCB boards to one side. And once the one side soldered down, it's not going to go anywhere. And to me, the soldering is essentially a two-step process. I'll add a little solder, and then I'll go back and push pressure on the 3 gauge and heat the joint a second time, and that helps to flow the solder all the way through. And once the one side of the 2 stock rails was done, I flipped the jig over to the other side and started doing the other side. I sort of start in the middle and work my way out. That way there's not really a buildup of errors or whatnot. And then once the entire stock rails have been done on both sides, you're ready to move on and do, I think in this case I'll do the frogs next. We'll see in a few seconds. But I also use a sort of a small sort of separate version to hold the jigs. Now I use those Fast Track version of all these as little weights, and they fit nicely inside of these. So you'll see the Fast Track stock and frog pointer right there's a frog cutter, and I use them to hold everything in place. You have to use something with a weight to hold it all down. Some of them can even try to flex a little bit, but if you put weight on it, it's flat, so it doesn't really matter. So at this point, I'm done doing the diverging rails, and again, the diverging rails mostly loose, except for around the frog itself, basically, and moving it back and forth to get it in the right alignment before putting it in, and then using the 3-point gauges to hold it in what appears to be as close to the proper alignment as possible. I find if the gauges are happy, the track tends to be right. And when you have a problem with the track and you put the gauges on it, the gauges will be tight or whatnot in the place, indicating that you've got your problem. And that's the other NMR metal gauge, which is very useful for different points in this. The frogs themselves is a really important thing to get it in, just push it in and out just right. But again, I found that the frog's in the right place when the gauges are all happy. So if you can put the frog back and forth and the gauges all fit, that definitely helps. I've also been putting just a new piece of PCB board into the gap, and basically if the PCB board is gapped right, then the frog tends to be gapped, or the tracks tend to be gapped right. This is also the same for the guardrails. I have some old tracks. If you look at my old videos, you can see the old locos bouncing in a few places. that was generally the guardrails and the diverging rails being too close to the rails. Even though it seemed fine with various versions of gauges, when I checked it, when I put a PCB board in there and reheated the joint, it'd go tink, and that would help it to reset the rail, and it would get rid of the problem for the most part. And then doing the same thing with the frogs, this time the other side of the frog. Once it's in place, I don't try to mess too much with the frog itself in there. I don't like to loosen my original frog joint. And then here's the guardrails being bent and cut. Again, the side of the frog thing has a little tiny hole in it, so you can put the guardrails in there and bend them. And then I make in this case, I think they're longer than they necessarily had to be, but being a longer guardrail is certainly not going to hurt anything if you keep the wheel in the right place. And again, using a PCB board to keep the alignment away from the main rail in the right place. And then this is one where the first one you can still pivot. So I try to get the first one and then make sure everything seems right around it, because if it's not right, it's hard to change it when there's multiple ones done. But if the first one isn't quite in, you can adjust it easily. And once it seems right, go ahead and do all the other things there. Keeping in mind that the guardrails on the other side of the gaps, that's again why those gaps are so critical, where the gaps get placed. It keeps again, you want to keep it from shorting, but if the gaps aren't in the right place, everything becomes difficult. And it's very small, there's very little room. I don't know how you Z-scale people do it. It's quite impressive because it's small enough in N-scale. And once the edges are bent, go ahead and flatten the ends of the guardrails. And again, you want to tip off that little bit of the corner so that the wheels have sort of a guiding flange as it goes in there. The flanges aren't pushed off. And again, that first one, put down a bit of solder and then hold it in the right place and make sure it's in the right place before you go ahead and add the other ones, because readjusting it is not nearly as easy once the other ones are down. It's not so bad with just that first one. But at that point, you've got all your frogs in, your stock rails in, and your diverging rails are in. Now I'm just doing the end of the diverging rail. Basically, again, using that same PCB board as a gap for the first one. So it should be sort of about right. And then if you do it right, it won't stick either. This is something that used to stick when I wasn't as good at doing this. Snap off the ends, and now you've got your basic turnout done. And again, that little screwdriver, if you ease it under, you can pop the whole thing out, and it fits on top of basically your 3D printed bed. And you want to make sure that you do your rails. You have to. I had it in the wrong place. I almost cut my own diverging rail. And there's also, it's included as well, a little jig to help do the gapping as well. It's a little V-notch gap, a V-notch gap tool, and a sacrificial one. So you put the V-notch so you can see what you're doing. On the other side has a sacrificial. So you cut through the sacrificial. It helps the saw blade works much better with a sacrificial piece of plastic. And then you isolate the frog. I go ahead and I'll take on the ends of the rail that go into the little joiners, because you have to put little joiners on the end. I'll go ahead and tip off the corners and the little bit of the bottom so the joiners slip on. As an old guy, I found it very frustrating getting those joiners on, but if you tip off those corner edges, joiners slip on real nice and easy. And then once the whole thing is set for the tying onto the tie buds, I go ahead and add some solder to the places I'm going to need to add solder to later, because I'm going to have to solder on the wires. And then I use Pliobond, also get it from Fast Track still. It's a nice contact cement. Don't use but so much of it in so many places. Make sure you don't use it where the diverging tracks move, because that's a big, huge mistake. And if you need to, you can remove this and the tracks fairly easily. If you heat them up on the 3D printer, they pull right off for the most part. Let the Pliobond sit for 20 minutes, and then you can add it to the bottom of the tracks. After that is when you're going to end up having to do the whole thing with the giant board, or some form of, you have to program the Arduino if you're using my method. However you're using it, I don't know. I used an Arduino and servos. It works fairly well, at least for me at this point in time. You can get them all on Colts. It's all going to be included in one thing. And if you like it, give it a like, give it a make, show me what you got, and get it on Colts. And let's see some trains run. This was really long hand-laid tracks and a really long video, and you really went on and on and on and on and on about the trains and the turnouts, and you on and on and on. And the song itself tacked on and on and on and on. The train wasn't that long.